Well, thank you for the opportunity to talk. It's going to be quite a different talk to the previous one, even though we're both in the geoscience area, the underground, the subsurface. We are really starting out on a big project, and we are here to attract you statisticians and mathematicians to come and help us with some big challenges. I think Schlumberger are well down the road with their work, looking at seismic acquisition and seismic interpretation. But our project is a new project. It's £31 million from the government to develop a test centre, 2 test centres for the underground. We'll be producing a lot of data, and a lot of data that we would like to use and also display. And what I'm really here to say is that we are open to suggestions. We really are here, we're new kids on the block in this kind of area, and we want to know what mathematics and statistics can help us with. So hopefully this will be a very broad introduction to what we're trying to do. It's not a particularly statistical or mathematical presentation. It's really just to introduce you to what we are doing in our 2 test sites here in Britain. So it's about real-time monitoring of the underground for researchers, industry and the public. It's not really commercial. It's not really about exploration as Schlumberger would be, or Halliburton's would be. This is more of a public sector science science to collect evidence and information about the underground to, for example, inform regulators, to understand what's happening in the subsurface, to help us manage the subsurface, the underground, better. So it's a much less commercial activity. It's not about getting oil out of the ground. Anyway, I will continue with this, and I hope you'll get it as I continue. So I guess the background to our bid to the government was that the underground is really important for the low carbon transition. So if we want to go from a hydrocarbons economy to one which is broader and less dependent on emissions of carbon dioxide and other greenhouse gases, we probably will have to use the underground in various ways. So we might have to do more geothermal, hot dry rock. We might have to do more district heating geothermal. We might have to do more mine water heating. So if you're not familiar with that, the fact that mine areas, coal mining areas, have warm water under them that you can use. We might have to use shale gas because some people would argue that it's a lower carbon alternative to coal. So in energy, it's clear that the underground might have an importance in that area. For low carbon transition, it's more likely, as we continue on our business as usual course, that we'll need carbon capture and storage. If you're not familiar with that, it's the idea that we can take industrial carbon dioxide from power stations, from concrete, from cement factories or ammonia factories, and bury it underground, dispose of it underground. It has been done a little bit. It's not been done on an industrial scale, but it may be a solution. And it's dependent on the underground, on understanding how the processes in the subsurface either make carbon dioxide storage possible or not possible. And generally storage as well. So one solution, for example, that you may have heard of for grid scale intermittency related to the use of renewables is compressed air energy storage. It's one of the few technical solutions to actually providing grid scale energy at a scale that makes a sort of difference. Hydrogen storage, we talk about hydrogen as another way of delivering energy, and that again will probably involve the underground, because if we're going to use a lot of hydrogen, we'll probably need to store it in the geological underground, because it will be the only sort of space that will be large enough to do it on a scale that matters industrially. So I hope you're getting the idea that what we're essentially saying is that you'll need the underground to do many of these things. And in order to do that, we'll have to understand it much better than we do now. We understand, I would say, the atmosphere pretty well, because we've been testing and measuring it for a very long time. We understand the oceans very well, but actually we don't understand the underground very well. So how much potential is there for these things? Can these technology be done sustainably? And many of these are science questions. And what I essentially did when I wrote the proposal for UK GEOS is I said to the government, if you want to do these things, you're going to have to understand it better, so we'll need some test sites to do it. And luckily they agreed with me. So we have £31 million, as I said. That's the British Geological Survey. If you're unfamiliar with who we are, we're the National Geoscience Institute of the UK. We have about 750 people, and we are public sector, so we receive government money to do science. We're part of the NERC, Natural Environment Research Council. So we've got £31 million, and we have 2 test sites that we're developing. At the moment, we are about the same level of progress in both sites. On the left is the Glasgow Geothermal Research Field site, which will collect an awful lot of data on heat in the underground, on water flow, on all kinds of activities that relate to whether geothermal heat from coal mines underneath Glasgow could be a feasible option for delivering heat to the people of Glasgow, for example, quite cheaply. The Cheshire Energy Research Field site, which is not far from Ellesmere Port, not far from Chester, is looking at deeper stuff. So it's looking at carbon capture and storage, perhaps compressed air energy storage, perhaps shale gas, a whole range of other activities. So if you ask me what it's going to be, it's really essentially going to be at loads and loads of boreholes, loads and loads of wells with lots of sensors and instruments down those holes and those wells. And we will be collecting data at very high rates of production, probably not the sorts of thing that meteorologists are used to, but still relatively high levels of collection of data. This is an example from the Glasgow Geothermal Energy Field site. So you can see at the bottom there, lots of Glasgow is underlain by coal mines. The water in them is quite warm. The fact that they are mined, that these rocks are mined, means the water moves around very fast, which means that if you take heat out, it probably replenishes quite quickly. If you didn't have those mines, it wouldn't happen so quickly, which makes it a possibility for taking warm water. So our questions are, is there enough heat down there? A fairly simple question. What's the most efficient way of getting the heat out? How fast does the heat get replenished? These are all questions which we'll only answer by drilling loads of holes, putting instruments down those holes, and measuring and understanding and producing that data. The Glasgow site is more complicated. We're looking at a large number of boreholes. That's completely the wrong place, actually. Oh, no, that is the right place, sorry. That's the Glasgow site. It's towards the eastern part of Glasgow. Here are some of the boreholes that we're going to set. Only 3 boreholes at this site. I'm not going to go into too much detail, but essentially it's a place to collect lots of data, seismological data, data on groundwater, data on tilt, data on ground motion, all kinds of things, much further beyond really what Schlumberger would normally collect, for example. The Cheshire Energy Research Facility is going to be about 50 boreholes between about 50 and 1,200 meters in depth, 8 kilometers of drilling, 3 kilometers of core, that's the rock that you actually take out, about 1,800 sensors, 5 kilometers of fiber optic cable, lots of very, very detailed seismology, for example. So we'll be testing this site with a very, very high level of scrutiny, if you like, at what's happening in the underground as we do experiments, as we simply observe the baseline, because no one has ever observed what groundwater does at the level of scrutiny that we're going to do. So how does groundwater move, for example? How does the local how do local things affect its movement? And groundwater is very important in the UK, for example. So for the Cheshire site, we have several arrays. This is the groundwater baseline array. We'll have 15 boreholes. We'll have 5 times 100 meter boreholes. We'll have lots of telemetry, lots of automated capability. Essentially collecting lots of information on groundwater. How does it change? What makes it change? The seismic baseline array, which will be, again, very high resolution. The array description, 10 seismometers in boreholes, some quite deep, some shallower. Essentially looking at what the baseline seismology of this area is. When we start doing experiments, these instrumented boreholes will really come into their own, because we'll be being able to understand how, for example, compressed air energy storage, how feasible it is, how feasible shale gas and hydraulic fracturing might be, what are the possibilities for groundwater contamination following hydraulic fracturing, what are the possibilities for induced seismicity following hydraulic fracturing. All of these instrumented boreholes will help us understand that in detail. Array 3 is a deep well, which is going to have a deep single seismometer in it, and other experiments will be carried out, possibly experiments into injecting carbon dioxide into sandstones in the area. These are just geological cross-sections of the area of the deep well. The fourth array will be a multi-scale array, which is looking partly at, for example, resistivity tomography. So we're going to run resistivity tests in these wells, so looking at how fluids in the rocks influence the resistivity, and using that as a technique to understand how fluids flow under the in the subsurface. So, and that might have value, for example, for understanding how landfill sites leak, for example, or how fluids move in oil reservoirs or whatever. So we're testing how, for example, resistivity tomography might be used in the subsurface. So you might say, what kind of science questions will we be looking at? Well, we'll be looking at, for example, shale gas. There have been some ideas about, could you use microwaves to do hydraulic fracturing as opposed to high pressure water? Can you do shale gas and geothermal at the same time in the same wells? Groundwater science. So as I've said several times before, can we understand groundwater better? Compressed air energy storage. What are the best rocks to do it? Where is it feasible? Where isn't it feasible? Carbon capture and storage. How do you inject? What's the best way to inject carbon dioxide? How does it stay down there? What are the biological interactions? Gas storage. So gas storage is very important to this country. We store about 10 days of gas, even though we need to store much more. That's probably because we had a lot in the North Sea. But we need to store gas better than we do, and probably at a larger scale for security of supply. And geothermal as well. If we really want to decarbonize heat in the UK, you could argue that for lots of domestic use, geothermal is the answer. So those are the things. One of the important, really important principles of the whole project is that everything that we produce, and I think Carl will, who's going to speak after me, will say, is everything that we're going to produce is going to be available to everyone. And we've been working on this. Essentially, we're going to put all the seismic data that we collect on the web in as close to real time as possible, all the groundwater data, the ground motion data, every kind of data, every kind of thing that we collect from all these sensors we'll make available on the web. We're kind of doing this already, but this is something that we're going to try and do in a much more comprehensive way. You might say, why? Well, it's partly around for the public, so that the public can see what's happening. This is partly about assurance and public assurance that, you know, that we do manage the subsurface properly, so it has a democratization or democratic principle in a sense. For scientists, for obviously for research and innovation, so our colleagues at Schlumberger or Halliburton, you know, would like to use some of the kit we're using for new ideas. Maybe they'd like to collect that. And for industry and for other scientists. So generally, that is one of the most important parts of the project. So I'm just going to hand over to Carl, who's more of an informatics person, and then we will finish with a brief summary.
Thank you. So as Mike said, I'm sort of leading the informatics side of this project, and I won't spend too long, so I'll skim through it, but anyone wants to know more about it, we've got a lunch break coming up. So in designing the sort of web presence or the delivery of the data platform, we're sort of trying to satisfy a whole bunch of different audiences. So we're sort of taking a design-led approach and go through various sort of workshops and consultation processes to figure out what form we deliver the data in. And we've got a whole range of different user groups that we need to consider. And I won't go through them all, but I think probably the three most important are researchers that are going to be doing the science to answer the questions Mike has posed. The concerned members of the public or interested members of the public who just want to know more about what is this facility and what does it mean for them. Forgot my third one. And the internal staff really, who need to maintain this system and understand what the facility is doing at the moment, how the equipment is performing, and oversee its management. And we've been creating these personas, but this is all just feeding into our understanding of what does the website need to deliver. But one of the the best ways that we've got to sort of understand what we think this facility needs to do and how the data needs to be delivered is that we've got 2 sites already, one in the Vale of Pickering in North Yorkshire and one over in Lancashire, that are just small monitoring sites that are observing the atmospheric conditions, they're observing groundwater parameters like we're going to be gathering in Cheshire. These are very near to locations that have been given licenses for shale gas exploration. So we've got an insight into what people's concerns are and the way that the data needs to be delivered from those. And it's terrible on the screen, but if you can make it out, there's a very faint yellow line. Sorry about that. This is methane gas from the Vale of Pickering site. And what we've been doing recently is presenting, well, our assumption was, let's show the last 7 days worth of data. That's what people might be interested in. So what you see is not much happening, not much happening, not much happening, big spike, and then nothing. So then we started getting phone calls and emails and basically inquiries going, what's happening, what are you hiding, because that looks suspicious. But if you sort of zoom out a little bit, and it's still not great on the screen, but that spike that I just showed you is there, but there's more all over. And actually it came back online within a day. So, and if I zoom out further, back to sort of June 2017, the one we were just looking at is over here, and it's dwarfed by 2 other events. So the public want to know what that means, why there's gaps, maybe like the Kepler data, why have we got gaps? So what we want to do is not only make the data available to scientists to conduct research, where we might ultimately give you a CSV and a bunch of metadata, we also want to present this information in a more meaningful way to some of the other audiences and perhaps overlay some meaning on it, or provide some metadata alongside it. We've done a little experiment where we knew that there was an error with our telemetry systems, so we just sort of overlay that there's a faint colour there, and when you click on a little icon you get a little description. What we won't have in the next few years is the manpower to do all that manually, so we need systems that are going to spot these anomalies, perhaps explain the patterns as well as the anomalies, but we need to overlay on these systems some information, because A, we don't have the manpower to spot them, and B, we might not have the manpower to fend off inquiries about so many different sensors that are going to be published. One example of a system that's already out there that sort of does this public engagement side quite well is sort of this gauge map, which is the river levels, and this is from just outside Cambridge on the River Cam, which I took yesterday. You see they've got this sort of flooding possible, below typical range going into drought, and this is bobbling along the bottom. So, and that's available for every single of the river gauges that the Environment Agency are publishing. So we're aiming to not only provide websites that maybe can present this sort of context to the data, but do it in a way like the EA have done, the Environment Agency, and provide the APIs, the programming interfaces, in an open way so people can consume the data themselves and interpret it as they see fit, and put it into their own websites, their own systems. So what I'm not sure you covered, Mike, was that this project it started last year. It's a 3-year period where we've got to construct these boreholes. So we've got to drill these 100 or thereabouts boreholes, instrument them, build the digital infrastructure, the websites, the databases that are going to store it, the telemetry network. So we've got a 1 gigabit per second telemetry network that's being built in Cheshire, and we're going to have an in-field data centre. So we've got to do all that, and then the facility is ready come April 2020. From then on, there's 15 years where this is operational. So the data is going to grow and get bigger and bigger. And we're not entirely sure what the challenges will be yet, because we don't know what the research proposals people are going to come and what experiments are going to be conducted there. So we need to be really flexible. So at the moment, I'm very much concerned with making sure that we know all the data that we're gathering as part of this baseline. So if I just go back, actually, our things are going to change seasonally. So we're trying to create this baseline model. So at what point do we say that's our bulk data set that we analyse and say this is typical range and these are the anomalies? So we're probably going to have to wait until some point during 2021 to do that. But we probably don't have the resources right now to really throw data science tools at this problem. So what we've done is we've sort of reached out to people like NERC Data Labs and Centre for Ecology and Hydrology, and the guys behind this are based in Lancaster, to sort of get them to take on some of the challenge for us, and maybe that's an area we can sort of explore. So what we're going to do is we're going to provide the data, we're going to explain what the data is, we're going to explain what the potential applications of that data are. And if I just skip forward, this was a paper that was published earlier this year. Well, it says June, so now. Looking at anomaly detection. So this was using the two sites, the one in Vale of Pickering and Lancashire, looking at groundwater data and trying to spot when equipment might fail. So this is more for the maintenance of the facility rather than the public, but we've got the algorithms, we've got the idea, we've got the data, but what we probably don't have is the resources to turn that into a fully functioning service. So that's where NERC Data Labs are suggesting they can step in, and this is their slide really. This is what NERC Data Labs plan to deliver. So they're going to take our algorithm, our data, and turn that into a Dockerized open source solution that runs off the Jasmine network. So they're going to take a big bulk data load, they're going to analyse it, they're going to get the service up and running, but then they're going to drip feed it with the real-time data that we're exposing through open APIs that we're publishing. So I've only really touched on groundwater, but beyond that there's the fibre optic stuff, there's the seismic, there's plenty of other subjects, and we've got about 4 posters knocking around in that room over there, so if you want to come and chat to us, we'll just be around.
I'm just going to round up quickly, and just to say that I mean, what Carl's basically concentrated on there has been the challenges we have over supplying this data in a form that people can understand, including the public or regulators, the Environment Agency, the government, whatever. And that is a challenge. But I guess in the end what we're looking at is science to inform our understanding of the subsurface. So in the long run we're looking at forecasting. Can we forecast groundwater levels, for example, with climate change? Can we forecast landslides, for example? Can we see connections between things that hitherto haven't been established? Connections between very different things that you wouldn't think were connected, that are happening in the subsurface. Can we understand the whole subsurface system better from collecting all this data? What are the things that this data will help us understand the surface better? And what Carl has particularly concentrated on there, which is the display on information and data that we, that we can make it better, ourselves better at displaying data. So I suppose the conclusions are, it's what I would call the first geological macroscope. So you're familiar with a microscope, it's looking at small things. A macroscope is a big thing that you put lots of sensors over to try and understand. It's really the first thing of this type that's ever been done in the UK, and really it's quite unusual anywhere else in the world. We're going to listen to the underground, we're going to collect data, provide lots of data for everyone for free. And I think it's quite a new scientific area because no one's really done this before with any kind of detail. So hopefully that's given you a flavour of what we're trying to do. And we're really at the beginning, and I'm really here to say hello to all the mathematicians and statisticians in the audience, and let's talk about how you might help us develop this new area. That's it, thanks.
Good, thank you. Any questions for Michael or Carl? Yeah, just a practical question. You talked about fibre optics. Are you going to have a single fibre joining many wells?
You'll have to ask the specialist who's developing that, but I can certainly answer it for you. I'm not certain myself.
I believe the idea is we've got this infield data centre that's got servers, and where possible, they're going to be strung down one hole, back up, down the next one, back up.
That would be the ideal way to do it.
You're in a difficult position with regards to the sensitivities regards the shale industry. So the shale industry will have a lot of money for you, and you yourselves will try and present yourselves as independent. How can you afford to do that?
Well, we don't take any money from the shale industry. Simple as that.
Can you afford not to?
We can afford to do it because we.
Can you really be effective if you don't have the resources they can put in to actually doing the kind of experiment that they want to do?
Okay, so again, one of the principles of this is that it's independent. So at no time were we prepared to accept money from the shale gas industry. That may sound, difficult and perhaps self-defeating, but in the end, we felt that we were positioning ourselves to do science that would inform the regulator, that would reassure the public, that would provide the answers that the public legitimately, the questions that the public legitimately ask about groundwater contamination, and for example.
Do you have a budget for it?
So we have quite a large budget to establish this. So, we took a decision not to work with shale gas companies to take shale gas money, but the site that we have set up in Cheshire is close to a site that may get permission to frack, and so we can use our equipment, which will be, of a very high resolution, high quality to monitor a frack to a very high level of scrutiny and detail. So it's been a very difficult game, but essentially we've had to separate ourselves from the shale gas industry, but simultaneously know what they want to do. So we have fixed that. But of course the company may not get a license. It's quite very likely that it won't, I would say. In which case we'll work on other areas, but it would be extremely interesting for us. And I wouldn't deny this, that it would be extremely interesting if a full-scale frack was to take place at that site, because we would be very well set up to monitor it. Yes.
A mundane question. Could you tell us the location of the site in Cheshire? Is it near the Dee estuary?
Yeah. Well, it's just north of there. It's actually very close to the Mersey estuary. It's very close to the Manchester Ship Canal, within a few hundred metres of the Manchester Ship Canal. It's an area
Just left of Runcorn.
Yes, that's right. Just west of left or west, depending on which way you look at it, of Runcorn. Yeah.
Okay.
It's in an area on the M56 as you drive to North Wales. On the right, you see a lot of wind turbines. It's in that area. It's an area of around 20 square kilometres, where we'll probably have around 60 boreholes.
Thank you.
So you already mentioned it, but so it's going to be a public access website. People will be looking at the data. You provide them, like the example you showed. You have too short a time window, and everything is easy to misinterpret. It seems there's a real danger that you're going to have a huge amount of information coming back from the public that you won't be able to handle.
True, and I think Carl was, reflecting on that, and something that we do need to think about. We've also thought about how you deal with something which is clearly an error in the equipment. I must admit, I was quite taken with this idea that I forgot the TV show, but there's a TV show that's one of these reality shows where, to stop the problem of people swearing in real time, they slightly hold back the broadcast. And I wonder if there's a similar thing that we could do here, because we do want to hear from the public actually about their legitimate concerns and if they are reacting to something which is a problem. So, for example, during a frack, we would like to put all the data online. We would be measuring it, so we could do that. But what we wouldn't want is the public reacting to something which is just, spurious. So, how do we deal with that? But again, that's our role. We are a public sector organisation with the British Geological Survey. We're supposed to provide information. That's what taxpayers are paying for. So,
I think one thing we've looked at various test beds around the world that potentially been the focus of controversial applications, and none of them seem to have this proactive flagging up of this might be an issue. We know you might have spotted it, and this is what we think about it. I can't really find examples of that. But what seems to be effective generally after the event is to put a notice saying we know there is a thing and we are actively working on it. A full explanation is on its way, and people tend to be reasonable and know that you're working on it and it will come, so they'll check back. So if we can proactively spot that there is an issue and put that message out there, and then have a reasonable time frame to put a more considered response, that might be a route we go.
I think we'll have one more question. Yeah.
I think it might be an opportunity for a really interesting use of crowdsourcing, though, in that, just following on from what you're saying, because if you think you're going to have a large audience looking at a large data set, which you're going to have a job dealing with in a reasonable time frame, then maybe turn it on its head and say, look, if you want to look at this data set and start labeling areas of concern, areas of interest for us, we can then run algorithms over this now labeled data set and say, and start picking out patterns. Some of them may be completely,
Sure.
not of interest, but some might be ones that it would help you focus the efforts for your algorithms to look at.
it would be also interesting to link things like social media to reactions on social media to data. That's ever been done.
Yeah, sure.
Really fascinating.
Absolutely.
So that then it becomes a social science thing. How do people react to things that are happening underground? What does that mean?
I think that brings us to lunch, and we gather back at 2 o'clock. But first, can we thank all our speakers again?